Hello? Hello? Anyone there? Looking for signs of life?
I'm technically alive.
Oh, good, good. You'd be surprised. Sometimes someone goes into the chat room and there is no reaction. And I just say hello to myself for 10 minutes. So that's why I sound a little strange, perhaps.
It's pretty understandable.
All right, let me just double check. Someone on the YouTube side says there's no sound. No, okay. They are mistaken. Let me just get the spreadsheets open here.
Oh, mine is, well, I'm Sarah St. Jacques, and then C0494048. Usually I just like to listen if you do something, and if I have a question, I'll let you know, but not right now. Okay, then I guess I'll think of a couple questions. Okay, yeah, no, I'll figure some question out, I guess. Because I mean, I do have questions. I just got to figure out exactly how I'm gonna word it and then find a question that helps identify what my problem is, kind of thing. So I have to take
Sure.
like a few minutes.
Sure, yeah, no problem. Yeah. I don't know, now the desktop audio is super loud, I think. Ooh. Or maybe it was just her. Let's see. Maybe? Okay. Maybe I'll just announce it in the chat as well. Go, that's better. Now we know. It's quiet. I turned my mic off just out of habit.
is this session we can ask questions about pretty much anything you've learned through the entire semester?
Yes, because the final exam will potentially cover everything. So I want to be ready. Absolutely.
Okay. Okay, so I have a little bit of a half-developed question because I was always a little bit confused when it came to, like, the graphing and
Sure,
taking
sure.
a bunch of different like, taking the steps that you use and then putting it actually on the graph. Like, I understood the whole the charts and taking, like, the curves and, all that, but I've always had a problem putting it on the graph. So
Right.
I'm looking at
Okay, so we're
chapter, like
looking at those last problems.
yeah, so, like, chapter 9, that's where I'm looking right now. Um, maybe
Keep
we could try doing, like, 1 or
Sure,
2
yeah.
of the questions and kind of working through, like
Okay, so let me just open up the problem book here. And see what we have. Okay, so we're going down to graphing, but it's really the end. Questions go up a little. So like 9.4, those are the ones you're looking at?
yeah, like 9.4, I'm looking at, like, 9.5.
Yeah, so 9.5 has everything. I can't get to how many pages are there? Oh, wow. 9.5 is the whole thing from start to finish, where you make the table, you go through each step, and an hour later, you have a graph. the the questions before that try to sort of isolate the steps. We have one just for asymptotic behavior, for example. It would be 9. I don't know. Let's get 9.1, just asymptotic behavior, and then stop. 9.2, just step, what do we call it? 3, increasing, decreasing behavior, just to sort of isolate them so it doesn't take too long and get used to what is in that step. Then what is in the concavity step. And then finally, whether I've done it myself or it's given to me, I have to all put it in the graph. So 9.4 tries to isolate that graphing step so that I don't waste time. If the other steps are perfectly fine, like it seems they are for you, we can focus on just the graphing aspect.
Yeah, that makes sense.
Now, I don't really know which one. We've done some of these, so let's skip the
I
first
can
few.
I can look at my notes and I can tell you which ones we've done, so we'll do a different one.
Yeah, I wouldn't want to redo them. I don't think we went very high, but do check. 1, 2, 3, maybe 4. I doubt we got to 5, but we can certainly check. Now, I'm gonna open, while you look, just open something to write on as well.
1, 2, 3. We did 5
Oh, we did
twice.
5. Wow,
We
okay.
did 5 twice because remember there was a mishap.
Oh, that was 5. Oh, yeah, yeah. No, get away. Okay, let me check how that looks. It looks pretty good. All right. Have a preference? Or do you want to start one first? Or yeah, really whatever you want, right?
Sorry, I cut out there for a second.
Um, do you have a number, or do you want to try it first and then see where you get stuck? It really depends. I don't. Sometimes especially close to an exam, it is tricky. It's deceptive sometimes to just sit back and listen to me do it, and then you have to do it on your own, and it's not quite the same. So maybe we should do one. I should do one, and then you try one and see how far you get. I don't know, whatever you prefer, really.
Okay, that sounds good. Maybe we could do like, I don't know.
They're all, I have no idea which ones are good, right? They're all the same.
Yeah.
I don't think we've done 6 and up, right?
Yeah, so maybe if you did 7 and then I just did 8. And then I
Sure,
came
sure.
back
Let's see
and
what 7. Yeah. And
see
then
what
you
you
can
got.
also take a picture and send it to me, and then we can have a look at it, and no
Yeah,
one
for
else
sure.
can see it and stuff. So, okay, so if we look at 7, for example, it's so nice. I have no idea what the answer is, what the graph looks like. No idea. I can't remember these at all. Some of them I've never done because I always start with 1 and we never get to the high numbers. So we have some stuff. Let's write them down. Why not? I have some function values. Nothing is undefined. So they really have to make it clear. And there's nothing mentioned, so there's no vertical asymptote or anything. Uh, Now, if it helps you, don't feel restricted to use that grid. Draw your own graph because sometimes it's nicer to be a little flexible on the scale and put things a little bit where it's convenient. Now, I don't know what's coming. I look at other x values, 0, 2, 3. So 0, 2, 3, 4 seem to be the main players here. I should probably leave myself more space there, whatever. So let's just start with something equally spread out here. Not 4 first, then 4. I don't know if I have enough space here, right? That's okay. And of course 0. So we have a 0 value of y, so that's a point there. At 3, I'm somewhere down here. I might adjust it later, depending on how much space I need for ups and downs and bending and stuff. So this is really, don't feel uh, too restricted by this. I can easily erase this and move it down a little if I have to have more space. It's totally fine. I see people feel very restricted. Well, if I put that point there, I can never move it again. No, you can do whatever you want. As long as I have the y value marked off as -3. Okay, so we have long-term behavior. Maybe I'll put that at the top as well. Limit x goes to infinity of my function. So I'm thinking this might be something like a polynomial. I don't know for sure yet, but it could be, in that it's defined everywhere. But we'll see. I don't know for sure. So I'm going up on either side. Okay, so these arrows are just reminders for me. Now we get to the derivative information. So I'll just summarize it over here. I have my number line. I have only 3. Oh, okay. And my derivative. At 3, it is 0. And left of 3, it is negative. Right of 3, it is positive. So I'm going to have, this line is too long here. Downslope, horizontal tangent, upslope. Little cup there at 3, which I know where the point is. I might want to shift it, but so far so good. I've given myself some space. Then we have our concavity information, which is all the second derivative information. Just sort of copy it again in case someone wants to watch this and they don't have the book in front of them. Second derivative. These are my separators. So second derivative at 0 is 0. At 2 is also 0. And it goes positive, negative, positive. So I'm bending up, bending down, bending up. Maybe not a full turn, but still. So x equal to 0, x equal to 2 are inflection points. So let's see, do I have y values for them? I have a y value for 0, and they didn't give me a y value for x equal to 2 on purpose, so that I have flexibility and I can draw a nice graph. If I have a point there I have to go through, it gets all wobbly. So sometimes they do it for convenience. So I can choose a y value that is giving me a nice smooth graph because they don't say what it is. The only thing I know is it's probably between 0 and 3 here in this gap. So I'm going to come down all the way through this point, all the way to this turning point, and then go up, and I'll go up through this x-intercept. Okay, that looks pretty straightforward. And now I'm bending down, which makes sense, until I get, no, I'm bending up. That's interesting. I'm bending up to 0. Now, x equal to 0 doesn't feature in my increasing decreasing behavior table, so I can't go horizontal tangent there, right? But it can come at an angle and then I guess change again down. That is super weird. Can happen. And then it's going to have to change again at 2 to get this cup shape, this bottom turning point. So it turns through 2 all the way to 4. So let's at least do that. And none of those have 0 or vertical tangents because they would have featured in the derivative. So it's a little strange. Let me just clean up my binder lines here. I think we have enough space. Space here. Let's just focus on the right section. So it's a little steep. Try and have a bend before I become super vertical. Just stop right there. It's fine. A little bendy. I didn't give myself enough space. There's not much happening on the left of the graph. So if I were to do this again, I would shift this y-axis to the left and give myself some nice space here. But oh well. I'm committed to this now, though in a test you can of course just reset this and try again if you feel the space is a little limited. Then we have to turn through to x equal to 0, x equal to 2. So let's just keep bending. Let's suppose that's my point there. I'm trying to meet it. It doesn't have to bend the same way. This is, I guess it could be, I doubt it's a polynomial. Doesn't matter. So now I have to bend down without going horizontal here because it doesn't feature in my increasing decreasing behavior. So I need an angle. Now I can have that angle fairly slight, which would help if I zoom in a little bit. So maybe there is a little bit of a bend there. Oh, now I don't meet the point perfectly. Let's move this down a little. It's a little bit of trial and error to get that smoothness nice, like so. Meet each other. There we go. Something like that. And then for some reason, it's going to bend at an angle, bending up. So I think the only catch here really is that I'm tempted to think of simple functions having a horizontal tangent here in order for the concavity to change, but that doesn't need to happen. I don't know what this function is, right? It could be weird, though maybe a polynomial could do this, but I'm not sure. So let me just double check. Did I do everything I should? It comes down all the way through to the turning point and then up. So increasing decreasing behavior is good. Then it's bending up. Could be slight. Bending up, then changing at 0 to a slight down bend, then changing through to a full turn concave up from 2 on. Yeah, that looks pretty good. And again, it would be a little easier to do if I give myself more space here where the detail is, instead of wasting all this space, right? Oops, let's get rid of that. All right, how does that feel?
Good, yeah, I was drawing it like alongside you while I was doing it, and mine was a little bit more dramatic, but I think I still got the right shape.
Yeah, I think the key is to not be horizontal at 0. I think that's something, as someone who grades it, I would look out for that.
Okay, it wasn't, so we're good.
And then give yourself more space maybe to show the bend and not be straight. It's so easy. The bend is so slight based on my positioning that it's so tempting to make a straight line here or something wobbly. Whereas if I sort of zoomed in on this, I'm drawing with a mouse, that's the mistake. If I zoomed in and gave myself a bigger space on the page, it would be easier for sure. So there's a little bit of planning. I didn't know where the key parts will be, and it turns out I don't need this much space on the left. So if I were to do this in a test or a final, I would do a preliminary one and see, okay, no, I'm going to zoom in and make this bottom right section bigger. And if I were to make a new page, for example, or I draw in pencil and erase it, or whatever options you have, I would say, okay, so this is now number 7. I'm going to set myself up for a better time here. And do it this way. And give myself the space where I need the space.
So I sent you over email of the picture of what I did thing. So
Okay, I'll check.
it just said it was question 9.7.
Yeah, I see it. Hold on. Oopsie. Yeah, that's better than mine.
It's dramatic.
No, but you want to sort of exaggerate it, right? They don't tell me what the Y value is. So they do it on purpose so that I can sort of exaggerate those properties. If they put the Y value at x equal to 2, high or low, it would make it very tricky to draw smoothly. So they leave it out so you can put it wherever you want, of course, within reason in that gap. Yeah, I like it. It looks good. Yeah.
Okay, so at least I have the right idea.
Yeah, absolutely. And I mean, so not every question has all the things to look out for. This one doesn't have any asymptotes, doesn't have a vertical tangent line, because I don't have any derivatives undefined. So there's no potential for anything like that. But having it nice and smooth is its own challenge. Sometimes having asymptotes, vertical asymptotes and things make it easier sometimes. So I just want to see all the little things. So I'm guessing looking at 8, I have undefined at 0, which in this way would mean a vertical asymptote, though it could be a hole. There's some variety, but vertical asymptote is the easiest to go with. And then the derivatives are both existing everywhere. So this one looks like a rational function, which is usually fairly easy to draw. So that's certainly a good one to try. If I look at 9, I'm guessing 9 is very similar to the one we did. There's no undefined function value. All the derivatives have values. I'm guessing it's very similar. Oh, that's it. All right then. So 8 and 9, yeah, let me know. And I mean, you don't have to do it in this session, right? I think to just be sure you have a solid grip on this, try 8 and 9, send it to me. We can very easily check it. It's not a problem. And then you feel more confident maybe, or if maybe you're confident right now. Really, it's whatever you need.
Okay, that's great.
Someone is waiting for a oral test, so let me do that while you plan your next move. Take them to the private. Hello. You want to do your test? No reaction. That's nice. Okay. Oh, there they are. Oh, no, it's not.
Oh,
Hello. Sorry, yes.
okay.
Yeah, you can turn that back on. Good observation. Okay. Let
Yes.
me just be right back.
Yes. Okay. Yes. I'm Yasumi. Yasuumi. Yes. Sorry. Um, Mass one. Okay. G048167. Okay. Also, what we gonna do for oral test? I'm not sure. Yes. Okay. Okay. Yes. Uh, so derivative is differential at a point. So how to say? Okay. Yes. Mhm. Okay. Um. Oh, how to say? So derivative is the differential. So for example, if I have a parabola like y equals x squared and like a point x is 1, y equals 1. And in that point, it has a word, lean. No. Uh, okay. So yes. Yes, yes. I mean slope. So that is fit uh, the slope at point. Oh, it's difficult to explain. Oh, okay, yes. Yes. Okay. Vertical asymptote. Uh, Vertical asymptote is our imaginary line that is not existed on the graph, and a graph is reached to the infinity or negative infinity at uh, the graph is close to that vertical line. Okay. Hmm. Yes. So okay. So that is a second step. F dash. That point is existed on the function, and critical point three. Increasing and decreasing is changing at point. Oops. Critical point. Oh. Oh. Yes. Oh. So critical point is a point that it change our behavior from increasing to decreasing or decreasing to increasing. So it should be exist on a function point, that is first, and also uh, change our behavior at that point. Um, oh, okay. Yes. E to the x. Is e to the x. Yes, but I've confused about critical point. Okay. Yes. Mm, yeah. Uh, Function t is something e to the kt. So something is uh, Ah, okay. So proportional to the population growth. So dt dy is kt. Oh, really? Yes, okay. So growth rate of population. Yes. Ah, uh, yes. Okay. And yes. Okay. Mm, okay. Yes. Thank you. Yes. Oh, sorry. When it is Monday morning. Okay. All right. Mm, as always. Yes. Okay. 173. Okay. 3 hours. Okay. Yes. Thank you. Yes. You too. Bye.
Okay, I am back. Just had to do a little private test with someone. Are new. Welcome, George. This is the end of the semester, so there isn't really a schedule. This is the last couple of days, but there can be a schedule next year. So maybe just bookmark it or follow or whatever you need to do. And then next year, things will pick up, I think around the 14th. Oh, let's see. What does January look like? We
I'm pretty
start
sure it's the
January
11th.
11th, right, right. I knew it was a teen. Do we start on Monday? Oh, we usually start on a Tuesday. 11th somewhere, yes. That's where things will pick up again. But this week is pretty dead, and then it's Christmas time. Yeah. That is pretty much the end for today, I believe. Someone asked a question in the Discord chat, but I'm not sure. Understand the question. I would not leave my oral test for Sunday. That I think is a disaster waiting to happen because everyone's going to scramble get their test in. Though it opened November 1st, I don't know why we have to leave it until the very last day. So it's first come first serve. You might not get your oral test in. That's too bad. Anyway, let me know in an email if you have any questions in the meantime. Otherwise, we'll have a session tomorrow again. Until then, bye bye.